Okay, so it looks like you've made it to your final challenge here, folks. Congratulations. You are so close to having your geologic calendar done. What you're viewing right now will be a short little presentation on some of the big Precambrian events. If you're looking on how to illustrate some of these things that you've been reading about, just spend about, I don't know, 3 or 4 minutes, 5 minutes watching this video right here, and you'll know exactly what you need to do. So I'm just going to start the slideshow from the beginning. Now that might have sounded like a Tyrannosaurus Rex to you, but in reality, that's the sound that Miss McMillan makes when she walks through the door each morning. And for that epic burn, I want you to put your hands in the air, stand up, and then shout in your loudest voice so the whole class stops and looks at you. I want you to yell, "I smell burnt McMillan." I'll just wait for you to do that. Go ahead. See, everyone's looking at you like you're awesome. All right, so we're going to move on, and I'm going to show you some of the events. So the Earth's crust finally cools and solidifies. That's one of the first events. Remember what we learned back in our unit on star stuff, that solar systems form from these giant nebula, these giant clouds of gas and dust, stellar nurseries. And the largest clumps end up becoming stars, fusing their hydrogen atoms together. The smaller clumps end up becoming planets, which will eventually form into solid. Now, one of the big cool things here with our crust is that it didn't actually become solid. It didn't cool down from this nebula formation until February 9th or 10th, depending on how you do your calculations. One of the things that happened somewhere between January 1st and February 10th is a large Mars-sized object actually collided with the Earth. And that's what we think actually began the birth of our moon. See, our moon is made out of metals, minerals, that are found almost exclusively deep inside the Earth. And it's always puzzled people how the moon could be made out of things that are deep inside the Earth. This is how we think it happened. So there was a rogue planet about the size of Mars that collided with the Earth, and we might have had a solid crust early on in January, but the collision remelted the entire surface and blew a big chunk of the Earth into close orbit, and that eventually clumped together and formed into the moon. So, about 500 million years pass before the Earth's crust finally cools, solidifies, and becomes solid rock. We just simply can't find rocks older than approximately 4 billion years ago in the past. So the first 500 million years, all erased, all gone from that collision. So in January, maybe even February, you can have some drawings, some pictures that might look a little bit like this. A lava planet cooling down and eventually becoming solid. And so you can see here the different pictures in different stages of this thing turning solid. So finally we get to the point where the planet has cooled down enough that the entire thing is solid. So one of the next big things that we find in our geologic calendar, the first living things, primitive bacteria, very likely chemotrophs that were pulling food, nutrients directly from the water in the form of molecules. And so primitive bacteria, if you're looking for ideas, I think an awesome one would be to draw a bacteria that looks a little primitive, if you know what I mean. So if you want to draw cave skins, like leopard skins and caveman style on a bacteria, and they're all just kind of walking around saying ugh like a bunch of cave people, you could do that. Now, another event that happens in the Precambrian is that there's this giant tear, this giant rift that actually starts to pull Minnesota apart. It rips the crust. Here you can see a map of what that actually looked like. The yellow and the green rocks here are volcanic rocks, and this is where the tearing took place. See, over here in this part of Minnesota was moving towards the west, and this part of North America here, Iowa and Wisconsin, was moving towards the east. And the magma came in from underneath and filled in the gap as it started to split apart. So something was pulling the crust apart. Now it shut down. We're not entirely sure why or how, but if you've ever been along the north shore of Lake Superior here in Minnesota, you'll notice all of these volcanic looking rocks. They're all dark rocks, black, large crystals. It's really, really cool. But that's the event that happened right there. And according to my calculations, and probably yours as well, that's going to show up in your calendar. Let's see here, let me flip through my page. That's going to show up in your calendar right around October 3rd. So that might be a good idea for October 3rd, or for the month of October. You could show that. Now, other cool things that are going on, other Precambrian events, we have the autotrophs, the photosynthesizers, that slowly contaminate the Earth's atmosphere with this toxic gas. See, they take in sunlight, they take in carbon dioxide, they release oxygen into the atmosphere. So the Earth's atmosphere didn't start with a lot of oxygen, but over time, the bacteria built it up, the autotrophs built it up, the photosynthesizers, and we eventually have oxygen in our atmosphere. Remember, this is part of the argument for why Mars has life. It's red. The red came from oxygen, from bacteria. And of course, oxygen also makes ozone, which gives us a nice protection of the ozone layer around the Earth, which actually makes dry land possible. Without ozone, our planet gets bombarded with ultraviolet radiation, which, if we go to the next page, you'll see the horrifying effects of ultraviolet radiation. See, am I right, or am I right on this one? All right, so moving on. Other Precambrian events, we have the Iron Range that forms in Minnesota. Here's a map of Minnesota. You can see Virginia, Hibbing, Grand Rapids, and this stretch of red right through here on this map, these are iron deposits that formed in Minnesota. And that happened, let's see if I look at my chart here, that happened in July, about 2 billion years ago. And it didn't actually happen until we had enough oxygen in the atmosphere to oxidize that iron and turn it into hematite. So this red band through here, what makes Minnesota, the Iron Range, so famous is the hematite that's there. Then we have another event that's worth taking note of. I believe this one happens in, let's see, this one would be July 31st, according to my calculations, about 1.9 billion years ago, a mountain range called the Precambrian mountain range. This is what the St. Cloud granites are made out of. And so there was a mountain range that ran through this whole part of North America. Where are those mountains today? They've all been eroded away, but they were here at one point. And we can see the St. Cloud granite. That's kind of the roots of this ancient mountain system here. All right, then I thought I'd show you a few other Precambrian things. There's another giant mountain range that's in and touches Minnesota. This would be the second mountain range that forms. This would be an October event, but it's called the Transcontinental Arch. And this mountain range, if you've been paying attention in geography, is no longer here either. It's been completely worn down. So that we have flat plains through here, and then we have a new set of mountains, the Rocky Mountains. So in all this time, mountains have come and gone. And then some other Precambrian events that might be worth noting. Some of the first multicellular organisms come along during the Precambrian, and that would be, I believe, in July 14th, about 2.1 billion years ago. So bacteria start kind of working together collectively. And as we all have talked about, if you want to go fast, you go alone. If you want to go far, you go with others. So multicellular life, that's where things really start picking up. And multicellular organisms begin to show up towards the end of the Precambrian. The first true invertebrate animals, like sea anemones and jellyfish and things like that, and a whole bunch of really bizarre critters that we know not a whole lot about. So even as early as November 8th, they start showing up. And some of these creatures, we don't even know what they look like. The fossil over here looks like a jellyfish, but some of these other things, we have imprints of these fossils. We don't have the slightest clue what these things look like when they were alive, because they're so bizarre, so unusual, and they're extinct and they're not around today. So pretty interesting stuff. All right, so Precambrian ends approximately 570 million years ago. I know that you're upset, just like these young ladies are here, but that's going to wrap up our quick video review of some of the major events in the Precambrian. Hopefully that gives you some ideas of what you can fill in for some of your months. For any months that you have just blank, like nothing to put down, I know April's going to be a blank month. August might be too. Look to see what was happening the month prior. Maybe there's more of that. Like for example in March. Since there was life showing up in February and it was really primitive, maybe in March it's still there, maybe a little less primitive. That might be an idea of what you can draw. So we're going to bop out